In level 3, we will be given the value of a trig function, and we have to work backwards to find the angle. So, looking at this first example, number 4, we want to find the value of an angle theta on the interval pi over 2 to 3 pi over 2. So if we're looking between pi over 2 and 3 pi over 2, we're looking in quadrants 2 and 3. And we want to find an angle such that sine of theta equals 1/2. And remember that you are doing this in your head because you have your unit circle memorized, but we'll do it, I'll show you on the unit circle. So I want to find the angle that has a sine value of 1/2. That means we're going to have a y value of 1/2, or a y coordinate of 1/2. And that occurs at 5 pi over 6, where y is 1/2. So we get 5 pi over 6. In the next example, we're looking on the interval from 0 to 2 pi. So that's going to be the entire unit circle. And we want to find all values of theta such that tangent theta equals radical 3. We are also told that cosine theta is less than 0, so we have to have a negative x value. That means our x coordinate is going to be less than 0. And since tangent is supposed to come out positive, and we have a negative x value, that narrows it down to quadrant 3 only. We have negative x values in quadrant 2 and quadrants 2 and 3, but tangent would be negative in quadrant 2. So we have to be in quadrant 3. And we need to figure out which of these angles is going to give us a tangent, or a y over x, that comes out to be radical 3. And it's going to be either 7 pi over 6 or 4 pi over 3. So we have to figure out which one of those would come out to radical 3. And I'm going to go with 4 pi over 3. If I did negative root 3 over 2 divided by negative 1/2, that comes out to radical 3. So my answer must be 4 pi over 3. In the next example, we want to find all angles in the interval 0 to 2 pi where tangent of theta equals 0. 0 to 2 pi is our whole unit circle, and we want to find all angles where this happens. For tangent theta to equal 0, we need y over x to equal 0. And for that to happen, it must be one of our quadrantal angles, but we need the 0 on top. So we could have either 0 over 1 or 0 over negative 1. We would get a y value of 0 and an x value of 1 at when theta equals 0. And then also at pi, y over x would be 0 over negative 1. And then we would consider, since 0 is coterminal with 2 pi, that would be an answer too, except that we have a parenthesis here. So we're not actually going to include the angle 2 pi because of the parenthesis. So this happens at two places. That's when theta equals pi or 0. And in the last example, we are asked to evaluate inverse trig functions. Evaluating an inverse trig function basically is the same thing we were just doing, where you're going backwards, you know the value of a function, and you're trying to find the angle measure. But inverse trig functions have restricted domains, or trig functions have restricted domains, so the inverse trig function, actually its values can only occur at certain places in the unit circle. And for sine and tangent both, we're gonna be looking from negative pi over 2 to pi over 2. And don't worry about this now because we're going to study this more in depth later. But for specifically inverse trig functions, sine and tangent are going to be between those two values. And then cosine, we would always look between 0 and pi. Okay, so tangent inverse of -1, we want to look from negative pi over 2, which would be here, to pi over 2. Quadrants 1 and 4. But we have to think of quadrant 4 in terms of negative angles. And so tangent inverse of -1, we want to figure out where on this interval do we get a value of -1 for tangent. So we want y over x to equal -1. This is going to have to be either positive pi over 4 or negative pi over 4, which occur here and here, where the x and y coordinates are the same. For it to come out negative, it's going to have to be where 7 pi over 4 is, but we think of it between negative pi over 2 and pi over 2 is going to be negative pi over 4 would be our angle. And then for sine inverse, we do the same idea. We're going to look from negative pi over 2 to pi over 2. And sine inverse of negative radical 3 over 2, that means we need a y value of negative radical 3 over 2. And that's going to occur in quadrant 4, where we have a y value of negative radical 3 over 2 is right here at 5 pi over 3. But again, thinking of this in terms of negative angles, that angle would be negative pi over 3. But again, we're going to study actual inverse trig functions in depth later on. So don't worry so much about these problems yet. Focus more on these types of problems. That's what we'll be studying more in this skill in level 3. We'll give you the domain where you're supposed to search for the angle.